In 1957, broadcast television was a new, largely unquestioned authority in the British living room. Information delivered through this medium carried the weight of institutional truth. That April, the BBC's Panorama aired a report on a bumper crop of spaghetti in Switzerland. Viewers watched a family gather cooked strands of pasta directly from tree branches after a mild winter had supposedly wiped out the spaghetti weevil. The public didn't just believe it, they called in for gardening advice. The deception worked because it was delivered by Richard Dimbleby, a broadcaster whose face and voice were the era's visual shorthand for absolute authority. When a claim is wrapped in the recognizable aesthetic of a trusted institution, we often stop scrutinizing the data and start looking for the harvest. Today, our society relies on a different kind of gatekeeper, the peer-reviewed study. It is the filter we use to separate professional research from unsubstantiated claims. In 2015, journalist John Bohannon decided to stress test this filter. He fabricated a study claiming that chocolate accelerates weight loss, using a tiny sample size and statistically meaningless data designed to fall apart under the slightest expert review. Despite these flaws, the study was published by multiple journals and broadcast by global news outlets within 24 hours. The gatekeepers weren't just asleep, they were effectively non-existent. While traditional journals use a peer review bottleneck to verify quality, predatory journals offer a shortcut, charging researchers to publish while bypassing review entirely. Bohannon exposed this vulnerability, submitting a fake cancer cure paper to 304 open-access journals. 157 accepted the bogus study without noticing fatal errors. Research from the Universitat Oberta de Catalunya shows that this exploit is used by more than just hoaxers. Established scientists are increasingly using these exact channels just to survive the intense publish or perish culture of modern academia. The metrics prove the system is buckling. In 2023, the number of paper retractions surpassed 10,000, triple the volume we saw only a decade ago. When an academic's career depends on publication volume, the system begins to prioritize the speed of the output over the accuracy of the science. This failure isn't limited to fringe journals. Premier institutions are also compromised by the desire for media attention, seen in the 2010 #Arsenic Life scandal. NASA supported a study claiming that bacteria in Mono Lake could build DNA using arsenic instead of phosphorus. The findings were published in the journal Science, but subsequent replication attempts showed the study was fundamentally flawed. Editors were so eager to break a sexy story that they selected reviewers who were unlikely to challenge the findings. The pressure for a high-impact headline outweighed the duty of peer review. Even at the highest levels, the rigorous standards of science can become completely secondary to the relentless demands of the 24-hour news cycle. The damage of a fake study doesn't end with a retraction. It becomes zombie science, invalid data that persists and continues to influence new research. Bohannon's chocolate study and the fabricated pain research of Scott Rubin are still cited as factual evidence today. Retraction notices exist, but the scientific community is failing to read them. Many researchers simply copy citations from other papers without verifying the original source, allowing retracted data to stay in active circulation indefinitely. A single fraudulent paper acts as a foundational crack. If the base data is invalid, the structural integrity of every study built on top of it is compromised. These errors translate into real-world harm. Junk science dictates public health advice, misdirects millions in research funding, and creates a logical basis for the public to mistrust expert information. To fight back, journals use the Digital Object Identifier, or DOI. This digital fingerprint allows a retraction warning to broadcast across the network of citing papers. Systems like ORCID and Crossmark patch vulnerabilities by creating persistent identities for researchers and their data. But digital tracking only addresses the symptoms. Until the academic community stops rewarding publication volume over rigorous quality, our gatekeepers will remain vulnerable to anyone willing to stress test the system.